Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the Liskov Substitution principle, a cornerstone of solid principles in software design. It's often misunderstood, so let's clear things up.
Absolutely. I've always found LSP a bit tricky. The classic rectangle-square example is often cited, but what's the real core issue there?
Exactly. The problem isn't that a square is a rectangle mathematically, it's about behavioral substitution. If you have a function that modifies a rectangle's width and height independently, that breaks with a square, right? Because changing one automatically changes the other.
Right, you can't treat a square as a fully interchangeable rectangle. So inheritance isn't the solution here?
Precisely. The article champions composition and interfaces instead. Instead of inheriting from rectangle, square and rectangle would both implement a shape interface, each managing its area calculation independently. This avoids the unexpected behavior.
That makes perfect sense. So it's about ensuring that subtypes behave as expected within the context of their base type's contract. No surprises.
Exactly. The article also highlights real-world examples like payment processing. Having different payment processors, credit card, debit card, implement a common payment processor interface allows for flexible checkout services without needing to know the specific implementation details.
That's elegant. But what about common pitfalls? The article mentions unexpected exceptions and returning null where the base type doesn't.
Yeah, those are sneaky. A cached user repository, for instance, shouldn't throw an exception if the cache isn't initialized. It should gracefully return null, just like the base user repository. Similarly, a remote data fetcher should return an empty list if it fails to fetch data, not null, to maintain consistency with the base type's contract.
So how do we ensure LSP compliance? The article suggests contract tests and documenting pre- and post conditions. That seems crucial.
Absolutely. Contract tests verify that all subtypes meet the base type's contract, and clearly documenting pre- and post conditions, what the method requires and guarantees, helps prevent unexpected behavior and ensures everyone's on the same page.
I see. It's all about clear contracts and consistent behavior, right? Avoiding those "this behaves differently" comments.
Precisely. The article emphasizes that inheritance isn't a silver bullet. Composition often provides better flexibility and avoids LSP violations. It's about designing for substitutability and predictable behavior. And remember, consistent return types are key, avoiding unexpected nulls or exceptions.
This has been incredibly insightful. Thanks for breaking down LSP so clearly. I feel much more confident tackling it now.
My pleasure. Remember, understanding LSP leads to more robust and maintainable code. Stay tuned for our next episode on the open-closed principle. Thanks for listening to Tech Bytes and News. Goodbye.
Bye-bye.